Hello, class. Welcome to the virtual lecture where we will discuss the next major phase of our software engineering journey. So, up until this point, we've accomplished two major goals, motivations. The first of which is we've learned a lot of different collaboration tooling and technologies over the course of 12 different IT workshops. So we can make use of these technologies moving into the next leg of our um, of our semester, of our capstone project. And the second part is that we've all completed our dev cycle 0, which has been a lot of effectively like market analysis and planning in terms of what the requirements are for the application that we're going to be developing over the course of this capstone project for our touchless kiosk system. So at this juncture, we're now going to migrate into spending a majority of our time collaborating together across pods to actually create our application. And so with that said, I have already gone ahead and provided the necessary sets of instructions inside of our course repository here inside of 4010 capstones. We have that repo 4010 course resources. Inside of there is our capstone directory that has all of the instructions that help guide us to understand what happens in our dev cycle 0 that goes into the planning and the requirement analysis cycle. And then we move into an MVP development cycle. And then we'll move into the stakeholder feedback loop and adjustments. And then we'll see over the course of this particular lecture, the cyclical development that we'll then go ahead and adhere to try to produce a deployable application within the end of this semester. And so that's what we're really going to focus on today, is what is going to be the plans for November and December. And so this will really kind of lead us up into what we're going to be doing next lecture, where we're actually going to spend all of our lecture time having stand-ups and getting the teams to coordinate. So it's very important that you kind of have an understanding of what the intention of these dev cycles are going to be, so that we can roll into getting everyone's feature list embedded into our roadmap that's actually going to be hardened inside of our GitLab projects board, but also to go ahead and ensure that we can go ahead and start assigning tasks, and we can start doing stand-ups during our lecture hours so that we know what progress is being made and we know how we're going to intend to move forward. So a lot of the remaining portion of our class is going to be effectively administering and managing our pods together to ensure that we hit our weekly goals to the point of having something deployable by the end. Okay, with that said, let's take a look at the capstones folder. You'll see if you were to go in there, you have already, all the pods should have already now have finished capstone cycle 0, which now allows us to get into the more gritty, hands-on, application dev-driven portion of our projects. So in today's lecture, I want to go over the instructions for the capstone cycle 1, our capstone cycle 2, our capstone cycle 3, and our capstone cycle 4. And you'll see just by the very nature of this, we'll be able to adjust as we need over the course of the semester to ensure that we hit the target of our 4th cycle and the importance of each one of these. So I'm going to go ahead and move to the first PDF here. So moving out of our dev cycle 0, which was really our planning phase, our requirements analysis phase, we're going to move into dev cycle 1, which is going to be our MVP, our minimal viable product development, and to ensure that we have integration readiness. Now, what we've already know about what integration is from the IT workshops, is the ability for a pod to make each pod to be able to make a code base that can then be merged or integrated together to make a more holistic application from that. So when you're designing your code base at a per pod level, you have to think deeply on the architecture and actually talk and discuss amongst the various pods to ensure that your deliverables are going to be such that they can be seamlessly tied into other pods code bases. And so this is why modularity is going to be so important when we go and design and develop the various tasks at hand. And so some of these ideas, some of these patterns that you might be familiar with software design too, such as model view controller, helps define that kind of modularity between what is your model versus what is your controller model view and what is your view. So your view would be like your GUI, your controller would be what are the systems of inputs that your user might have to be able to to communicate with the back model, and the model would be your business logic. And then even the model itself might have a might rely on some kind of data persistence layer that it then communicates with some backend database. Not to be confused, MVC, not to be confused with MVP, which is what we're talking about. This is the minimal viable product. So this is a proof of concept build that kind of would produce a skeletal structure of what the application can do, and kind of is a complete version of the application itself, but a very basic, very feature deprived version of it that you could then use as that skeleton to kind of fatten up and pad out with more and more features that the end user might enjoy or utilize. But first, you worry about just getting the bones of your system in place. And that way you can start showing a deployed version to your stakeholders, and they can start giving you feedback. So in Dev Cycle 1, in the first phase of our development, this is what we're really going to focus on, this MVP development and integration with integration readiness. So a quick overview for this particular cycle, the MVP development cycle is going to focus really on creating that MVP, the minimum viable product, by implementing these isolated components and ensuring that they're ready for integration. This phase will build essential features that form the foundation of a functioning system, aligning with the agile principles we've discussed in lecture already. And then, of course, pods will complete tasks independently while adhering to guidelines for a unified code base. So we've talked about the importance of having a set of guidelines in which you follow that creates uniform syntax and coding conventions. So it's important that all pods agree on certain conventions so that you can seamlessly use or have an expectation of how one set of deliverables, one set of code that comes from pod A might go with pod 3, for instance. Okay, so with that said, because again, the motivation here is pods are independently working on code segments, but they're going to have to get merged or integrated together at the end of this cycle to create our MVP. So clearly the key objectives here is we will have our component isolation. We want to develop a system of components that are independent so we can prepare them for integration. If there are dependencies, there are all sorts of techniques we can use to try to cope with that. Say, for instance, if one pod is working on a user data structure and another pod is working on a system that requires a user data structure, this is why it's very important to have a lot of strong documentation about how things are expected to be modeled so that the pod that is going to depend on a particular data structure can mock or imitate that for the purposes of developing their deliverable. And so presumably, as long as the mocked data is an analog to what will be the delivered data type, then you can integrate those two together without having too many conflicts or issues occur as you start replacing your mock data with the actual data representations. Okay, so we need to focus on this component isolation so that each pod can independently deliver, of course, each week until we are able to integrate our code bases to have a deployed product. We also want to establish our core functionality. Here, we're going to build essential features that are needed to create our functional MVP for user testing and feedback. User testing and feedback is what we're going to be performing in the next cycle to the stakeholders. So the entire point of an MVP is to get a skeletal structure so we can get immediate feedback, not just in an abstract sense like you did during the interviews, but you show them a first pass draft of what this might look like in practice. And this will give you another round of more insightful feedback that you can use in the next development cycle. And then finally, what do we mean by integration readiness? I think we kind of covered this already, but what it really alludes to is this idea is that we want to ensure that all of our components are compatible and ready for system-wide integration so that everything that all the pods are delivering, they know that they have to deliver to this larger project, much like maybe a jigsaw puzzle where the pieces can seamlessly interconnect and create something more holistic, something that can then seamlessly do all the individual tasks and operations that are delivered and then actually produce a final result. So let's talk about how we can subdivide the cycle, our cycle task. So let's subdivide this into a couple parts. We have part one, which is going to be that core feature development. We'll have part two, which is going to be our integration preparation. We're going to have part three, which is going to be the collaborative code review and refinement. And so focusing on part one here, our objective is to implement the core functionalities identified by each pod in a requirements document. So again, this gives you a prelude. And of course, you've already read about this in Dev Cycle 0, but at this point, we should have started to merge all of our features and all of our expected roadmaps into one main roadmap that is going to aggregate all of the identified features from various pods together. So from that, we go, so using our requirements document as a basis, we're going to start being able to assign various tasks, but we're going to identify those tasks that are part of that kind of skeleton build, that minimum viable product build, just to get something that's very simple, a proof of concept that we can then start showing off to our end users, to our clients, to our stakeholders, to our investors. Stakeholders is the better blanket term, but when you hear that, a stakeholder can take on many roles, obviously. So this is going to include building those isolated components for each primary feature, where we try to limit or minimize the interdependency on those components. Now, clearly, you can't limit it completely. And so as you might have seen in one of the IT workshops, there's this idea of designing software using a microservice architecture as opposed to a monolithic architecture. Either way is actually achievable in building out an MVP build, because even in a monolithic system, you can modularize your code and package it up so that you can mock it if you don't have the actual code, the data that would come from those function calls from a particular package, and still have all that once it's deployed in a big monolithic state. So microservice and monolithic architectures don't really impede upon this idea of creating these kinds of what's the word I'm looking for? These core systems that are kind of modularized. We can do that using any kind of architecture scheme, but the importance is that we clearly communicate with the other pods to say, how are you going to package your code? How is it going to be interfaced with, hence an API? How does I in pod one make calls to your code in pod two? And then what are the expected results so that I can mock that as I need to as I develop things. So some of the core system features that we might identify from those requirements might be things like a user management system, right? That's core to how the system itself is going to use, maybe our data storage or our data persistence, maybe an interface with our any kind of specialized hardware, such as in this instance, we're using leap motion. So we'll have to know and and show as an example exactly how that's going to work in our minimal viable product in terms of producing an interaction. Super important because you need to get that feedback very early on so that if you have to make radical changes to the interface, you can do that. This is a time where you can make whatever radical changes you have based off of your assumptions so that you find something that works and then build on top of that. Uh, I find it kind of interesting. I think there's a lot of overlap with software engineering and actually good game design and game development. Uh, um, so where some of the master crafters in game design, game development hone in on finding a gameplay mechanic that works really well, and they'll throw out multiple mechanics, very simple, achievable things until they find something that's fun and insightful, and then they just build an entire game on top of that. So I feel like there's a lot of overlap in just being able to produce projects as a whole using this agile approach. Anyway, let's get back to the software engineering um, discussion. Okay, so we talked about developing our core system and what our core system, how that might break into. What are the subsystems or what are the systems inside of our application that have to be part of the MVP, that have to be part of a deliverable such that the stakeholder will use over the course or the life cycle of that application. And so this is the time you want to start exploring the implementation of those avenues and again the feedback on how frictionful or how useful those systems are, and whether they need to be expanded, whether they need to be diminished, or whether they have to be altered. For example, suppose that we put a lot of investment inside these leap motions and we find like that the interface system is too noisy or too unreliable to produce a good user experience, then perhaps that might be a signal to us that if all the stakeholders say the leap motion is not a good interface system, this is the instance very early on during the MVP that we might want to drop the leap motion and look into an alternate input scheme that allows users to interface with our touchless kiosk. And say, for example, maybe what we might do is we just create a browser app that opens a WebSocket to some backend server that allows you to interact with a canvas as a virtual mouse, where you can use your finger on a on side of your screen to move a virtual cursor on our kiosk, and then maybe use two fingers to depress to actually touch. And that might create a more seamless, better input device. This is the time we want to identify that as uh, as a input means that we want to build on top of. So clearly, these are some of the roles that the MVP will give to us. Okay, so on top of that, so besides defining our core system features that we can then kind of show off and test out on our stakeholders, we also need to develop the necessary APIs for these core systems just to ensure that we are passing data across our application as it needs to be and start to develop an API that will continually build on top of as we uh, build our system out. So from the MVP, we'll start defining our sets of our interface mechanisms, our APIs, and then we'll keep adding to that as we keep increasing the sets of features. So we're effectively going to grow out our application code base. And then we also need to establish the data persistence mechanisms for any required data, and just can kind of consider things that are important, like how scalable is our data persistence going to be, and how secure does it have to be? If there's like passwords, if there's private information, security is going to be a big concern. You don't want to just save passwords in plain text, for instance. You want to look at different authentication, authorization, and different ways to be able to maybe salt or protect things like passwords if they're going to go um, onto any of your own inside any of the application that we actually manage the data for. And in terms of scalability, if you have small amounts of data, maybe you can just write that into something like a text file, for instance. But if you have large volumes of data that you have to constantly query on, maybe a text file or just a CSV file might not be very effective if you were to scale it out to be, say, for instance, 1,000,000 rows of pieces of data. And so you might ask, well, how might this application get 1,000,000 rows of data? Suppose we're tracking logs of tutor schedules, right? And we want to keep a historical record that's going to grow over time. And with each student and each log, it's possible that this data can potentially explode in size. So think about how the data is generated to try to figure out what the scalability of it's going to be. Let's look at the next part here. So build our primary user interface. Of course, this is designed, our application is designed for a lot of prospective users to actually interface with, not through code, but through some GUI system. So we'll have to start to develop our GUI system that then communicates to our core functionalities, to our core systems, to go ahead and route to them a set of instructions or directives from the end user. It'll compute that inside the model and then produce that result back into our interface. So you'll have to start creating a binding between our user interface and our model. And again, a good scheme for this is a model view controller, which I'm hoping most of you have seen at least in software design 2. If not, we can discuss that in greater detail in a next lecture or future lecture or whatnot, just to ensure everyone knows the basics. But I would recommend that everyone at least look at the IT workshop related to graphic user interfaces, as that should be covered. The model view controller scheme should be covered inside that workshop, at least topically. So here we would implement our basic UI components and the layouts that align with our system requirements. We'd want to set up a backend to support and connect those UI components with the core functionality, just like we said. And one thing we should think about with a UI is we should try to make it as consistent as possible between different application views. So as we build out the different subsystems of our application and we migrate or we pivot from, say, for instance, uh, the tutor view to, say, for instance, the prospective student view, there should be a common thread on how those views are shared so that you don't drastically change kind of your GUI logic or your GUI language where the user has to relearn how to interface with your system. There should be a consistency there, and we should think about that as we roll out our various versions of our application, and we'll get feedback from that as well on how frictionful, how easy or how difficult it is to use these applications from our stakeholders in the next cycle. And then also we want to be able to integrate these input and output devices. So we already talked about this with our gesture controls, or touchless sensors with the leap motion, or even to validate and verify in our next cycle whether this is an appropriate tool for what the objective is, and if it's not, to be able to drop this and find a replacement. Again, that's an important part of the MVP is we show very early builds to get feedback to know if we have to drastically change or minimally change, or how we can go ahead and pivot towards the next build or the next draft or version of our application as we keep iteratively and incrementally building it out. Okay, so in part 2, we have our integration preparation. The objective here is we want to prepare each component for integration by following the coding standards and API conventions established in cycle 0. Now, recall we have in the IT workshops, there is a IT workshop dedicated towards API and for documentation. Please refer to those 2 workshops to get really a fundamental understanding of how we might want to standardize our API calls and how we might properly create documentation for that. Anyway, so this is going to include all the concepts that were defined in those workshops, such as defining our API documentation, conducting the initial tests, and ensuring compatibility across components. Here we'll establish our API conventions. We'll probably go with our REST API endpoints, but I'm not going to necessarily require REST endpoints in any kind of microservice architecture. If you want to do particularly like some packaged Python modules that can be imported into an environment, and then you can then go ahead and make function calls on what gets imported, where you provided some set of parameters, it produces some sort of results. That's also a fine mechanism, right? So either of those would be appropriate, and both of those are different types of APIs. Just REST APIs are ones that are exposed towards being available through some kind of web service, so that it's available through the internet, as opposed to having to be locally downloaded and available just through your local platform. But again, since we run the hardware, either of these are going to be achievable results. I'll leave it up to the teams to decide what works best for this application. I will not influence your choice on that. Okay, we also have our document API specifications for things like user authentication, dashboard, gesture control, right? These are important things to standardize. You should also conduct unit tests for each isolated component. This allows you to be able to do a number of things. First of all, it's accountability for the pod to all other pods. When you share that unit test to other pods, they'll know exactly how the intended use of that code is going to be. But it also allows you to validate and verify the actual deliverable code as well, such that it'll pass all the tests that will be expected for it to be properly integrated into the full code base. And so, like, these unit tests then serve two purposes. It allows you to ensure that the code does all of the jobs it needs to do to service the application as a whole, but it also allows the team to communicate with all other teams of what the expectation for this code is, so that if another team has a requirement outside of the unit codes, they should communicate that with that pod, so that pod can add those unit tests in. This allows teams to be kind of accountable and agile to other teams, so that each deliverable fulfills the requirements of all other teams who might be dependent or be the stakeholders or clients on that team's deliverable feature or code. Okay, on top of that, we'll also want to implement any kind of error logging and basic security. Here, obviously, we want to track when errors occur. We want to log them so that we can go back and try to resolve or fix them, right? We don't want them just to go into some black void and just have like be non-responsive to issues that might be occurring inside of our system. So if something goes wrong, we want to be able to log it so that we can look at it later and make that another issue inside of our project board that we can then go back and address. And also, there's just basic security that you'll want to evaluate to make sure that we don't take the lazy way out of implementing convenience. So there's this constant concept in software development where if you were to create a spectrum, you have convenience on one side and security on the other. So it's super convenient to create a user system where you don't have passwords, right? You just type in your username, and that's really easy to implement. It's very frictionless for the end user. But then the problem with that is that anyone with a username could just log into that person's user profile. So you can create a security, you can add more security into that, which is going to take away the convenience factor, but it's going to provide you with the mechanism that people can't just easily log into someone else's user account. So here, there's always this delicate balance of how convenient or frictionless should a system be and how secure should it be. And we should always be mindful of the security aspect. And so it's always easy to lean into making things more convenient and kind of ignoring the security aspect. And that's why things are so vulnerable and compromised today. Okay, and then finally, we'll have this kind of collaborative code review and refinement. And here, the objective is to ensure that our code quality and compatibility through our peer review sessions. We'll actually use class time to effectively do stand-ups where each pod talks about what they're working on, what their deliverable is, what their progress is. And so, since I am guaranteed that everyone is available for our lecture time, we're going to spend a lot of our lecture times in November doing team stand-ups so we can very rapidly get task assigned to each pod, have pods very rapidly try to find working solutions and talk about them from a per class or per class perspective. So we talked about how stand-ups were before. We talked about sprints. We're going to be doing rapid sprints. So we're going to be doing, I don't know what the smaller segment of a sprint is, but it's going to be like 10-meter sprints so that we can try to get a deployable version of our application by the end of the semester, which is you could count on in weeks at this point. You probably count it's we probably have about 5 or 6 weeks left. So we have a lot of work to get done to get to a deployed state. So many of our lecture hours will be talking about what we've been able to do since the last stand-up. And so we will spend time for that, and that will be part of effectively the turn in for these for these dev cycles. And then, of course, from these feedback, this ensures that everyone's on the same page about who's doing what, how things are being delivered, what the expected timetables are, and what kind of changes have to be made between each stand-up and stand-up. Okay, so with that said, really our submission guidelines. So clearly our deliverables is to have a feature ready components, the code for each of our core features with the unit test, the API documentation, the error handling. Effectively, we need something that we can show off to the end user, right? So that we can start getting feedback very rapidly to know if some of our initial assumptions are correct in a kind of applicable deployed state. And on top of that, we need our consistent API documentation because we're going to grow this code base out. So we don't want to be developing systems without being able to then share with the other pods how to make calls to all of these various systems, right? We have to start creating a shared uh, library of code, of documentation that all the other pods will be able to refer to as they take in new tasks and develop on top of this MVP build that we will deliver upon. And then, of course, these are all going to be living documents, which means they're going to be subject to change throughout the entire agile life cycle as we develop further. And then, of course, we'll have this testing and review process. And so at this instance, it's not with the stakeholders. This is just going to be the results of like the unit test and whatever error logs we have, and like the pod to pod evaluations of what needs to occur to further enrich each deliverable. Say, for instance, if pod one is working on a user structure, pod two might have certain requirements that they want pod one to add into their sets of unit tests and into their core functionality and representation of that particular that kind of user data structure so that they can make better use of it in whatever they're working on. So pods can be kind of clients to other pods. In terms of our submission guidelines, we want to use all of the tooling that we've learned about in these IT workshops. So we're going to talk about like the GitHub projects, Kanban board. We'll talk about obviously providing the core feature implementations inside of the GitHub repo, providing the API documentation inside the GitHub repo. Here, this is Markdown. We shouldn't be using Markdown. We should be looking at the actual kind of GitHub pages using the same kind of formatting that traditional like Python API coding or REST API is provided in, right? Which isn't typically a Markdown. We want this to be as professionally deployed project as possible because, again, the core here is to build something that will be a crowning jewel inside of your portfolio. And then finally, any kind of testing and review summary here. We don't really have to worry. This is not as this will tie in more to what we're going to be doing in the future. So here, each pod will submit a report summarizing their unit test, peer review outcomes. It just ties into summarizing what we've talked about up here. And then we have a base rubric just so that you can kind of know what are the deliverables, what are those brief descriptions, and how weighted should each of these deliverables be. If we were to try to sum them up, clearly they're all very important. They're all critical for us moving to the next cycle. And I think I've really kind of broken all these down, so I'm not going to spend too much time talking about each of those. But remember, we should be updating our project boards throughout the entire process, because this is how pods are communicating with other pods. This is how team members are communicating with the other teams. This is how we create a journal legacy of our evolving code base from the time we initially build it out to the time where it's current right now. And presumably, code is always in a living state, so it should always be mutable. It's very rarely does it ever go into an immutable state. If it is, it's pretty much dead code or just legacy code. Okay, so from cycle 1, let's talk about moving then into our dev cycle 2, because we're going to cover the entire gambit inside this lecture so that everyone knows where we're going to go from today towards the last day of class and the end of the semester. So in Dev Cycle 2, we will have our user feedback and refinement. So the entire point of the MVP was so that we can start showing our stakeholders things that they've kind of requested that the system will have to do for them in a bare bones system. And so if there's some complex features that aren't part of the MVP, we can then talk about how we would add or pin those while showing it off the most basic build. But again, the idea here is there's some very kind of primitive basic assumptions we're making about our application, about how useful it is. And so we want to make sure those are true before we add on top of that. Again, that's the entire point of MVP. Very famously, this is like a development process that Nintendo goes through, where the lead developers will design a core mechanic and they'll see if it's fun, and if it's not, they drop it and they find another core mechanic. Once they find a simple core mechanic, they just build on top of that. Okay, so let's look at the cycle overview here. So the user feedback and refinement cycle focuses on gathering the user feedback, identifying the improvement areas, and refining the MVP based on real-world use cases and user interactions. Really, all this is saying is that we take the MVP, we show it to stakeholders, and we collect their feedback so that we know whether we were correct in our assumptions and do we have implementations that we can utilize to build the next features on top of, or do we make bad assumptions? Is there too much friction? Is there too much pain points in the current approach? And do we have to pivot at this point to an alternate approach that would make for a better base foundation that we can then build our feature set off of? So very critical to get early feedback, because it lets us know whether we're going in the right direction or the wrong direction, and so that we can pivot while it is easy to, as opposed to building upon on multiple complex feature sets onto something that's fundamentally broken and then having to rewire that, which could be nightmares. That's what leads to so much catastrophe in the futures when you build on a foundation of sand and not a foundation of stone. And so you want to test, right? You want to see how firm that foundation is before you start building on it. Okay, with that said, the key objectives for this particular dev cycle after we deploy our MVP is going to collect that user feedback. We'll conduct testing with the representative users to identify the key issues and improvement opportunities. So recall that each pod has its own set of independent stakeholders. Now, you might have, and by independent, I mean external to the pod itself, you'll have your stakeholders who might be identified inside the pod, and those are great to have. And you should also be contributing feedback while working on the application, but you're going to be doing that naturally as part of the developers who are taking on the task and doing something that works for you. Now it's time to take those external stakeholders, show them how something works, and get their feedback on how well, let's say, the interaction system works. How well does the user profiles effectively allow them to perform in the task that they need to accomplish with the application you have. How well is the data persistence in terms of accessibility or scalability or security? So here's a good opportunity to start having them actually play around with the basic version of the application and give you a early sense of whether this is the right or wrong direction to go with it. And then here we can enhance our documentation and training material. This just means we're going to provide clear, updated documentation to guide future users and developers. So as we start communicating users on how to use our application, we can start creating documentation, uniform documentation on how the application should be used by the end user. And so as we start developing documentation, as we start doing this testing, it gives us a chance, it affords us a chance to start producing documentation that will become the shared documentation for other users to know how to use our system effectively. Because again, all stakeholders, there should be information that flows throughout the entire process across all participants of the application, whether you're a developer, whether you're a client, whether you're going to be a user in some kind of fashion. Let's take a look at the cycle task here. So in part one, we have our user testing and feedback collection. So here we're going to conduct our user testing to gain those insights on the user experience, try to identify any kind of usability challenges, and to gather improvement suggestions. So we might be able to break this down into 3 different things where we might design some user testing scenarios. We might go ahead and conduct the user sessions, and then we compile and analyze this feedback. So it's not unlike kind of what the reviews we did before when we were in a more kind of theoretical space. Now we're going to be in a more applicable space, and then we can challenge some of the things that we had encountered or we have created during that process and actually go back and actually see what they look like in action. Okay, so in the second part, we're going to have this refinement and iteration. So the objective here is based on that user feedback, we want to start to refine the MVP to improve performance, usability, and functionality. So this part of the cycle isn't just about doing stakeholder, getting your user feedback, your stakeholder feedback, but you get that feedback and you actually mutate your system. You actually change the MVP to include those improvements for the usability or the functionality or the performance. If it's running too slow, finding ways to optimize it so that it's more responsive to the end user. So here we'll take, so the first part is get that feedback. The second is now let's actually update our system with that. So we might break this down into, say, for instance, implementing our high priority changes, ones that actually are going to affect the foundational function of our MVP. So to throw this out there, just as an example, suppose we use the leap motion and in the environment that we are trying to utilize it in, it is not a good fit. It's too buggy. It doesn't capture gestures accurately enough. It creates a very either lagged or just friction. Friction is like something that doesn't feel intuitive, something that feels painful to you, something that feels like it slows you down while trying to interface with the system and you hate using. It makes you feel disgusted to try to interface with that system. And so you might become apathetic towards it. You might hate that system. So if that's the case, there's no way to fix making the leap motion a very good kind of interface point, then at this point, we'd want to find an alternate approach and implement that into our MVP as well. And then we can go back, and again, this is a cycle. So then go back to after making these changes, you go back to your user who had the issue and see if those changes address that. So this might be to implement these like high priority changes that actually affect some of the fundamental assumptions we have on how the system should work. Maybe some system performance things. Clearly, when we're doing our MVP build, sometimes we are more concerned about getting a proof of concept working, but this might create very specific performance bottlenecks. It might create a lack of responsiveness in the system. So once we get an idea of what does work, we can get that feedback and then start planning out where in our system we might need to optimize performance. If it's not apparent to the end user that or to the growth of the system at large that something is suboptimal, we might not have to spend more of our development time trying to improve it. If it works good enough in all use cases, then we can move on to something more critical. But there might be times where we build a proof of concept, but it's in a suboptimal implementation. And so this would be an instance to identify where we can improve system performance that would make either scaling our system up or using the system to be better. And then obviously update our user interfaces. Typically, when you have an MVP build, you have very ugly user interfaces. We don't normally go ahead and spend too much time designing really nice interfaces when we're not even sure what all the feature sets are going to be, or whether the subsystems and whether the assumed some of the assumed implementations are even going to work well or not. So we might have dummy interface systems or mock interface systems, or just toy systems that are very basic, they're very ugly, they're proof of concept just to give the user the ability to interface with the with our application, with the understanding that we'll go back and based off their feedback, we can move things. We can go ahead and add new things. We can remove things if it's too cluttered, and then have an idea of how we're going to then redesign that interface based off of that feedback. So again, during the MVP build, we don't want to spend too much time making something that looks really pretty, right? We're just trying to make something functional, but then we get the feedback on how they're interacting with it, and that's going to guide us on how to update those user interfaces. And then we can spend that time to start making more updated user interfaces during this cycle. And then for part 3, we clearly have this documentation and training material. So the objective here is we want to update the documentation training materials to reflect refinements and provide clear guidance to future users and developers. So here, as we update our system based off of our feedback, that means, again, these are all living documents. So revise the API documentation after the cycle. Make sure it reflects what changes we've made based off of our stakeholder feedback. So now we can create user training material because we've had to show end users who are not developers on how to use our system. So we should take this opportunity, having to think deeply about how do we communicate to our stakeholders how to use the system, to actually create material that can then be shared with all others on how to use the system. And also we want to be able to document this user feedback along with resolution summaries. And we could do this with GitHub issues even, right? Where like we can use, and in fact, this should all be tracked inside of our deliverables. So our deliverables here is we have our user testing report. This is going to be documented as a GitHub issue. Each testing scenario, along with the key feedback and identified issues, can be logged in to our project, into our GitHub project, so that we can then grab those um, um, that insight that we get from the users, and then those can then be grabbed by pods to serve as now improvements to redefine or to update our MVP build with. And then we have our refined feature ready component. So here, each core feature requiring any refinement, right, has to be updated. So here we need to make documentation on what needs to be updated and has to be part of our project management system. And then under that is actually the progress of the pods updating those components inside of our MVP so that it reflects those changes. And of course, if we update our components, we have to update our documentation. And then finally, this user feedback summary report, which again, GitHub issue will document all the user feedback comprehensively. And so then we can update the feedback on whether it's resolved or pending or these other kinds of states that the feedback might have. So clearly, this is just different ways that we can use project management tools to take the feedback that's articulated from human to human, but put that into our project management software so that we can actually use this to ensure that all the feedback is addressed in an effective way. Okay, so let me see here. And again, the last page I have here is just going to be the weighted rubric of just kind of how important this is. We've already kind of discussed what each of these are, but I have the breakdown and explanation as part of this document. Don't really want to spend too much time just kind of walking through what we've spent a long time kind of discussing. But it's all there for you to be able to read through these documentations without me kind of uh, uh, giving my commentary on top of. And again, this is all just to ensure that everyone at both an individual level and all the pods understand what needs to happen between now and the end of the semester to ensure that we get towards a deployed, not only deployed project, but the postmortem phase, which I'll get into in the future. So here in our dev cycle 3, once we've built out our MVP and then gotten our stakeholders to go ahead and give us their initial impressions so that we know what refactoring we might need to do before we start using that as our foundation to build upon, well, our next dev cycle, which we'll just call 3 arbitrarily right now, since I'm just using integer counting to illustrate like the incremental phases we're going through. Well, now that we have a strong foundation and that we've kind of like validated it and verified it from our stakeholders, we can now use that as a basis for our feature expansion and any actual optimization. So now we can start building out all the features we've identified during our requirements analysis. And once we have the core systems built out, we can start actually reliably build on top of those to have the deep sets of features we might need. And of course, we've identified these features as being a high priority, medium priority, or low priority. We would prioritize trying to implement the high priorities at any time. And then we can have a very agile sets of cycles. So as we keep integrating features into our build, we can, various pods at different times can take in their stakeholders whenever necessary, get their feedback, and keep updating that way. And so the beautiful thing about this is, unlike the prior step where we were getting all of our stakeholder feedback for the foundational build, as we're doing our feature expansion, we could do it as a per feature addition so that each pod can independently just bring a stakeholder and say, how is this feature? How is this one feature we just developed? How might it be improved? How well does it service what you need from the software? And then that could be autonomous from all other pods and all other stakeholders so that each one gets validated, verified, and then included into the system. And then we can just keep rolling in our features from high priority to medium priority to low priority until effectively we hit actually a maximum number of features that we're comfortable with, or we hit the deadline in which we need to deploy. But at any time, as we're doing this feature integration and expansion, we always result in a deployable build. That should be critical, is that as we identify a feature and we start to append that into the system, that we can then launch the system, we could deploy it, and it's fully inclusive and works and does not break down, and it is now a new, more improved version of what we had before. And so that means at any time, once we have the MVP, we have something that we can show off at the end of the semester. And so it just then becomes, how much time do we have to include as much features as possible? So that's the nice thing about these kind of agile development cycles, is that once we have a working thing, we're just working to improve it until it grows and grows and grows. And then we're just like, okay, we can deploy this, or we can wait and deploy this bigger thing, or we can like, and then, the sky's the limit there. Of course, you don't want to get into feature creep. That's a whole nother problem, but we won't talk about that. That's why we do the requirements analysis. So presumably we know what features are high, low, and medium, and that helps diminish this idea of impulsive feature creep. Okay, so let's take a look at this cycle overview. So here, the feature expansion and optimization cycle focuses on adding the new priority features, enhancing systems, as I said before. The cycle builds on our refined MVP by expanding functionality and optimizing our resource management, ensuring a robust user-friendly system. Effectively, we're just polishing the system in any which way we could define what it means to be polished, whether that is making the GUI look as good as possible, making sure that our database, our data persistence is robust to try to improve responsiveness and improve how much RAM is consumed, like the resource management or burdens of our application that actually affects the usefulness of the application, scalability, its security, all these other things we might be concerned about. So let's just take a look at this particular set of objectives for this cycle. where we're talking about feature expansions. So here we would introduce new features, here implement additional functionalities identified in the user feedback and requirement analysis. So again, things we explored in Dev Cycle 0 during the planning phase. Here we could potentially also enhance performance, because keep in mind, we might just focus initially on just getting the system that works, a proof of concept model. And as we continually develop the system, we might have bottlenecks that occur simply because of, or brittleness, even bottlenecks or brittleness inside of our system architecture based off of some of these kind of naive assumptions. But now that we know how the system works, it gives us better intuition and a better understanding of how we might better refactor the system. So this would be a good opportunity on where we can refactor the system to be more tolerant, to be more robust, to be have better decoupling, to make use of better design practices that allows our system to be kind of expansive and minimize dependencies and all these other things that might be embedded in our system from the very early build. So here we might prioritize enhancing performance, not just at like a computational enhancement, but maybe like in a kind of abstracted design conceptual enhancement as well, where you might be able to use better modular design to improve the performance of your system and be able to scale out. So scaling is not just something that happens computationally, it's something that can happen in terms of kind of like a conceptual design way as well. And then also we need to update, obviously, testing documentation. Every time we expand and add a new feature, every time we enhance performance, every time we may redesign something to remove interdependencies, we have to make sure to revise our testing procedures, to revise our documentation to reflect these new added features or new optimizations that we've added in. Okay, let's take a quick look at the cycle tasks. So we can break these into a few parts. The first is going to be feature implementation. The second is system optimization. And the third is testing documentation update. This is what we just covered. So here, there's just line items, what we stated for feature implementations, where we add our high priority features. Here, this is just ranked priorities, the term I should have used here, because at this phase, this will be a cyclical phase. So we would prioritize the things that are ranked higher, and then we move to the medium, and then finally the lower, right? And so all of these feature expansions happen during this phase, but we clearly weight some more than others when pods decide to go ahead and grab them. Okay, anyway, then we also go ahead and we'll implement these additional functionalities. We'll develop the enhanced user interfaces. Clearly, we're looking to constantly, just like you're constantly adding features, you can constantly be doing user testing in terms of being able to identify how frictionful, how intuitive is your user interface, how well does it expose the underlying functionalities of your system, how easy is it to navigate, and keep developing and enhance that. That you can have consistency of your UIs across multiple views or pages, as well as how much it exposes of your underlying system. You don't want to clutter it too much, but you don't want to make it too bare bones. So that takes a lot of input and dev cycles just to be able to get right as well. And then finally, also, you can kind of expand your device integration. So here you might add support for additional input and output devices. So suppose, for instance, that the Leap motion does work well, but perhaps you might also consider in the future adding a microphone and a little bit of voice controls. Or suppose that you want to go ahead and also do like a web touch, where you can use a QR code, you launch a canvas, a web page that has just a canvas element that's able to grab the XY mouse coordinates and send that to our underlying system through WebSockets. These might be times where you can explore giving multiple input modes into the system, because those are effectively alternate feature expansions as well. We have our system optimization. We kind of talked about this a little bit, where we can optimize our resource management or enhance our system scalability in terms of just the architecture, the way that our system is designed to try to decouple dependencies or make real strong uses of abstractions and modularization. And also here we can also implement better error handling. So in an MVP build, we might rely more on identifying a system that works. Here we can start to embed better security measures and better error logging and better error handling that gives us a stronger fault tolerance. So instead of just letting the system crash, if it gets unexpected input, we can try to catch that unexpected input and then produce maybe an error message to the end user. So at this point, we can start making those niceties that create a more polished system. And then finally, we have our part 3, testing documentation update. Clearly, every time we go through a dev cycle, it's not just important that we update our code base, but we should update all of the connected test and documentation that connects to the code that's either been added or mutated. So this is an ongoing process. We never want our code to become kind of divorced or disconnected or become versioned past as in the past and not representative of the current state. So it's important that whenever we make changes to our code base, we find all of our code and tests and make those changes too. So again, our deliverables here, and we will try to track all of our deliverables through GitHub issues and GitHub projects so that all teams can see the progress updates, but not just teams, like this is all logged. So if you were to use this in to show off your skill sets, these will all have historical, these all be in a legacy system. So you could show how completely you use GitHub as a project management environment as opposed to just a place to dump your source code onto. And that'll help to illustrate that you're really kind of capable of working productively inside of a team-based environment. Anyway, let's look at the deliverables here. We have our feature implementation summary. So again, every time we add a new feature, we need to detail the descriptions, the task, the team members. Again, we're using GitHub project management tools for that, but that's a deliverable, right? Like that has to be communicated with the other teams. If you're going to do any kind of optimizations, whether it's through redesigning of data structures, whether it's improves the performance of the underlying application, whether you're changing out one kind of technology or the other, we should have a report that documents our optimization. So you want to have a document summarizing the optimizations made, challenges encountered, and other areas for future improvement. So it's not just optimizations that you might have currently completed, but maybe ideas on how you might improve it in the future so that that can be defined as a task for a next cycle of feature expansion or optimization. And then finally, we'll talk about also updating your API and user documentation, right? We already talked about that lots and lots of time, do it. And also any kind of testing reports. So again, do comprehensive reports of tests conducted on new features. So the assumption now is as you add each feature, you get a stakeholder and you test it, and then that the feedback, just like in the prior cycle, is then included into included into our system tools through a GitHub issue, for instance. So if there's something that needs to be addressed, if there's some kind of meaningful feedback, then we can assign that as an issue so that a pod can take that and further improve based off the feedback we're getting. And again, if you just want to get an idea of how weighted these sets are, they're all kind of important, they're all kind of necessary, but clearly some of these are going to be more important than others. Like for instance, feature implementation is arguably going to be more important to the deployment deliverable of our code than say maybe how effective we are at being able to insert that into project management. So this just gives you an idea of how that weighting might break down. But in my opinion, they're all important, but clearly some are more important than others. And then this is just that detailed breakdown, which I think I've already kind of covered for the most part. So I don't want to bog down too much. And then the final dev cycle, which we'll just label dev cycle 4, is going to be after all of our feature expansions and our effectively our implementations are done, and we're now ready to deploy our project and deliver it to our stakeholders. So this could be thought of as deployment and delivery, but even more importantly than just delivery, this is where we'll have a postmortem analysis. Postmortem analysis means that we do a reflection on our project of our entire dev cycle, of all of our dev cycles 0 through 3, and then we look at what the initial ideas were, and then we look at what's actually then been delivered, and we see what went right, what went wrong, How might we do this in the future? This is all very important things. These are ways that you'll know how to grow based off of doing a deep analysis of the entire dev cycle so that you know how to do things better in the future. Not just for this project or a project that is similar to this project, but for any project in the future, because you can probably abstract what happens in this project to any other kind of team-based project. Anyway, we'll go more into detail here. So the cycle overview is we'll have the deployment, and our postmortem analysis cycle focuses on delivering the completed project to our stakeholders through a comprehensive presentation and a live demo, right? We'll actually hook our, in this instance with the touchless kiosk, we'll hook the Raspberry Pis up. The client side kiosk will have probably some backend server that they connect to. We'll go ahead and get everything in an actual and deployed production environment. And then we'll be able to get our live stakeholders, and we'll effectively have like a release party, for lack of a better word, where we'll aggregate everyone together and we'll have presentations to show how to use the application. We'll let them use it. And effectively, this is like, this would be the equivalent in the real world of deploying your product to be sold, or delivering it to the client who can then use the software and ask questions about it. So this is the final deliverable of the project to your end client. So this cycle culminates in a celebration of project achievements, showcasing the application's full functionality, discussing the development challenges and successes, and engaging in reflection through postmortem analysis. So this first part is talking about the deployment, the applications being able to show off to all of your stakeholders how to use the application based off of their requirements, what they want from the software. But then from this next part, you want to think of as not being so specific towards the discussing development challenges and successes. That's not something that you would traditionally discuss with a client. That's what you would normally discuss with your project manager. So this part is trying to capture the kind of the postmortem review you would have with your project manager on what went right during the production of the application that you just delivered. And you can look about, oh, this is what we did really well, and these were the challenges, and these are things that were obstacles that slowed us down, that like and why we got slowed down by that. And so the reason why you want to do that postmortem analysis, it allows you to know how to improve in the future or what to avoid in the future. And the objectives here is clearly deploy the final application, to present the completed project, again, developing the social skills where you then show off everything you've built to the stakeholders who have a vested interest in using what you've built. And then these two kind of represent what you give to the client. This last one represents what you would do with like the senior, whoever the architect of the code is, or whoever the project manager might be, or say, for instance, the CTO or whatnot of your company, where you reflect on the project's outcomes, including team insights, challenges faced, solutions implemented, and lessons learned, identifying areas for future improvement. So a quick look at the cycle task for this particular dev cycle. We can break that down as we've already labeled it: the deployment and preparation, the presentation and demo preparation, and then finally the postmortem analysis. So here the objective is, on the first part, on deployment, is just to ensure that the system is fully deployed and ready for a smooth, stable live demonstration, right? You want to make sure that everything's working before you do a presentation of it. That's clear. That makes sense. Make sure that everything is finished before we actually then make it go live. So here you would complete your system integration testing and just make sure that all of your deployment documentation is also primed and ready to go. So far we've probably been working mostly in a kind of a developer environment. Here we would move to a production environment, and you want to make sure that any documentation consistent with how you would deploy the product in the real world and not in your developer space is included and defined. In the next part, final presentation and your demo, here the objective is to prepare presentation materials that effectively showcase the completed project, this would include live demos, feature walkthroughs, and some key points from your postmortem analysis, maybe about why features were included or weren't included. This is why. So sometimes there might be a relevance for your end users on why you've opted to make a decision for one thing over another. Here would be a good opportunity to include that detail. So this might include like developing your presentation structure on how you're going to do your demo, and then finally organize your live demo and your feature walkthrough, and just practice the presentation so that you can deliver it smoothly and professionally and effectively, and not kind of in a more amateur or staggered approach. And then finally, in our postmortem analysis preparation here, you would document the project strengths and successes. Here, you might identify the aspects of the project that were successful, such as some of the design decisions or technical achievements, or how well the team was able to come together to integrate the code. And then you can reflect on the challenges and obstacles. Here, you might discuss major challenges encountered, such as resource limitations or setbacks, technologies that were hard to maybe interface together, or whatever, right? Like whatever you thought might work and you came across a obstacle that took too long, or you were never able to implement correctly, that should be documented as well and articulated inside the postmortem analysis. And then finally, this is about personal growth. And so here you would be able to summarize your lessons learned, where you can highlight the main takeaways from the project, focusing on the skills you've acquired, some of the best practices you learned by having to do these system optimizations, and how you might improve over the future, even like potential strategies that can apply these lessons for future projects that you could see could carry over. So again, the deliverables we would say then would be the integrated system build, the deployment of the system, but also our deployment documentation. So how do you deploy the system once we launch it for other people to go ahead and use? The live demonstration, so it would be whatever your presentation materials are, like slides, demo scripts, any visual aids. That'll be something that we'll go ahead and take account of. And then finally, those post-mortem summary reports. Excellent. And so that is really going to cover the implementation cycles, which would really represent dev cycles 1, 2, and 3. And then finally, dev cycle 4 would be our deployment, and then our post-mortem analysis of everything that we've done. And that would lead us to the very end of the semester. So I think this has been a good kind of lecture, kind of summarizing what the roadmap for where we're going to go in the future is. In the next lecture, what I want everyone to do is be prepared to go ahead and look over all of the features from dev cycle 0, and we're actually going to spend our lecture ensuring that our roadmap is implemented and that every pod has assigned a task from that, starting from that lecture, and then the next lecture after that, we'll find out what progress was made. So this will give you some illumination into what we intend to do for the next lecture. If you have any questions, go ahead and send me a message on Discord. Thank you all for watching the video. And I will see you next lecture.